Gather all materials such as 6 400 milliliter beakers, 6 250 milliliter beakers, hot plate, timer, ice, thermometer, potassium iodate solution, sodium meta-bisulfate, starch solution, and sulfuric acid solution. First, you must prepare solution A beakers. Properly add 50 milliliters of potassium iodate solution and 100 milliliters of distilled water into 3 beakers. Then pour 100 milliliters of the potassium iodate solution plus 100 milliliters of distilled water into the 4th beaker. Afterwards, pour 25 milliliters of potassium iodate solution and 175 milliliters of distilled water into the 5th beaker. Lastly, add 50 milliliters of potassium iodate solution, 140 milliliters of distilled water, and 10 milliliters of sulfuric acid solution into the 6th beaker. To compose the solution B beakers, you must prepare the sodium meta-bisulfate solution by mixing 420 milliliters of distilled water to the bottle containing 16 grams of sodium meta-bisulfate and shaking it well. To make the starch solution, add 26 grams starch and 130 milliliters distilled water, then pour this paste into boiling water while stirring. Remember to use the solution when cooled. Next, pour 10 milliliters of potassium meta-bisulfate solution, 30 milliliters of starch solution, and 40 milliliters of distilled water into 6 separate beakers. Make sure you pour the solution into the correct containers, then repeat for the other beakers. Heat the 4th beaker to approximately 45 degrees Celsius. Cool the 5th beaker around 10 degrees Celsius. To begin the chemical reactions, first pour beaker 1B to beaker 1A and use a stopwatch to time the speed of the reactions. The second reaction occurred faster than the first due to the higher concentration of potassium iodate present. This reaction took much longer to react because of the low concentration of potassium iodate. In the 4th beaker, the speed of the reaction also took place fast due to the warm temperature, which increased kinetic energy during the redox process. The 5th beaker's reaction occurred at a very slow rate in cold temperature because it was the least kinetic energy out of all beakers. The last beaker took place the fastest because of the catalyst, sulfuric acid, and most effectively increased the speed of the chemical reaction. In the iodine clock reaction, potassium iodate and sodium meta-bisulfate reacts to form iodide and sulfate ions through the oxidation-reduction process. Moreover, iodine is the reagent that oxidizes into its elemental form. As a result, the starch forms the dark blue colored starch-iodine complex in the presence of iodine, an indicator of the end of the reaction.
For this experiment, we had decided to use the journal entry format. It is very descriptive and informative. Also, it allows a better overall idea about our project through the multiple daily recordings. Our project on the iodine clock reaction is about the formation of an iodine solution in a chemical complex. The discovery of iodine has been beneficial to us in the past, such as aiding us in disinfecting many Americans of the goiter skin disease prevailing in the 1900s. Also, it was an alternative form of gunpowder for Napoleon's army war. The history of iodine helps us understand its physical and chemical potentials.